Fusion Mobile, quality e-learning experience on the go.
Taking us today on measurement of heat energy. There are basic parameters we must consider. 1. When we talk about measuring heat energy, the topic before this one handled heat energy itself. And we'll say that heat is the form of energy, an internal energy, which can be transferred from a body to another and thereby causing change in temperature. Today we want to look into what heat depends on. First of all, I want to bring out 3 basic parameters which heat depends on. First, heat depends on mass of a body. For example, if you have 2 materials that are the same and you heat them for 3 hours and bring them down, you will notice that the smaller one will get cold first while the large one still retains heat. Secondly, heat depends on change in temperature. Change in temperature. When the temperature is hot, heat is acquired. When the temperature is cold, heat is lost. Then, thirdly, heat depends on nature of the material. Nature of the material. Considering nature of the material, if we have 2 objects of the same size, but one is metal and the other is wood, and I ask you to hold 2 of them on top of a stove or a gas cooker, you will drop the metal first, and after like 1 hour you are still holding the wood. Why? Because of the nature of the material. So the basic 3 parameters which heat depends on: 1. Mass of the material. 2. Change in temperature of the material. 3. Nature of the material. But nature of the material is amathematical and unpredictable. It can change anytime. So mathematically, we consider mass and temperature. So we'll say that heat depends on mass and change in temperature. And since proportionality sign there is a dummy sign, we have to bring in an equivalent, which now will introduce a constant. So we'll say that heat is equal to mc delta theta, where c is a constant known as specific heat capacity. What did I call it? I said specific heat capacity. Now, what is specific heat capacity? Look straight there on the slide. The specific heat capacity of a substance is the quantity of heat required to raise the temperature of a unit mass. A unit mass, in quotes, of a unit mass of a substance through a degree rise in temperature. While heat capacity is also doing the same job, but this time around not on a unit mass but on the whole mass. For example, if I have this to be a block divided into 4, 1 kilogram, specific heat capacity is interested only in one part, which is 1 kilogram, while heat capacity is interested in all of them. So we'll say that heat capacity of a body is the quantity of heat required to raise the temperature of the entire body through 1 degree rise in temperature. So, can I take you on the journey again? Heat depends on mass, change in temperature, nature of the material, and equation of heat is H equal to mc delta theta. Take note of this equation, is very important. Now we'll move over to hidden heat. That's what I call it. A kind of heat that is hidden. Is there, but you don't notice it, but you're seeing what it's doing. Why? Because you cannot notice the heat by changing temperature this time around. It's called latent heat. When you bring out your gas in the kitchen, bring your ice block from the freezer, drop it on the gas cooker or the burner, and allow it for like 3 minutes. You'll notice that some part of the block has changed into water. Bring it down, dip your hand into the water or the block. You will still notice that it's still as cold as it was. This time there is no change in temperature, but there is a change in state. So latent heat is that particular heat energy required to convert a substance from one state to another without any corresponding change in temperature. Please, my dear, take it down. Write it down now. It is the heat energy required to convert a substance from one state to another without a corresponding change in temperature. For example, latent heat of fusion is the heat energy required to convert a substance from its solid form to its liquid form without change in temperature. While the specific latent heat is that heat energy required to convert a unit mass. This time around, a unit mass is coming in. The other one is converting the entire mass. This one is only converting a unit mass. Converting a unit mass of a substance from one state to another without a corresponding change in temperature. The specific latent heat of vaporization, as the name implies, vaporization, is still specific latent heat, but this time around, at boiling point, liquid is converted to gas. So we'll say that the specific latent heat of vaporization of a substance is the quantity of heat required to change units of mass of a substance from liquid to vapor without change in temperature. You can relate the same to fusion. And now we discuss Newton's law of cooling states, which states that for a small difference of temperature between a body and the surroundings, the rate of gain or loss of heat by the body is proportional to the difference in temperature between the body and the surroundings. Okay, we'll now look at some effects of evaporation. And we said evaporation causes cooling. That is why after your exercise and you sit down a place, because the internal part of you is hot, there is evaporation of fluid through your body and you will cool down. Now let's take a look at the difference between evaporation and boiling. In evaporation, the change from liquid to vapor at temperature below normal boiling points, in fact at any temperature. While boiling, this is the change from liquid to vapor at the boiling point only, that is vaporization. At vaporization, it is at only boiling point. At vaporization, listen to me, vaporization is only at boiling point, while evaporation can occur at any temperature. The second one there says evaporation occurs at all temperature, while vaporization occurs at a fixed temperature, such as also boiling occurs at a fixed temperature. Temperature during evaporation is not steady. Temperature remains steady during boiling. Occurs only at the surface of a liquid, while boiling is a whole body phenomenon. Sublimation is a process whereby a substance changes from the solid to vapor state without going through the liquid state. Can you sit down there and tell me something you know that can sublime? Do you use camphor? Yes. Bring out your camphor. The camphor you use in your box, your cloth box. Put it in a box, put it in a pot, and place it on fire. You will not see any liquid until you find the camphor no more. It cannot change to liquid, rather it will change from solid directly to gas. So I want to place down some equations of heat here. First, we say that heat is equal to mc delta theta. Secondly, considering latent heat H equal to ml, where L there is the specific latent heat. And when we have a system where you heat up a body and it changes state and at the same time changes temperature. For example, if I have ice block at 0 degrees and I heat the ice block to water of 15 degrees, first of all, it changes from ice block, which is 0 degrees, to ice water, which is 0 degrees. So at that moment, we have change in states without any change in temperature. But now, it now changes temperature from 0 degrees to 15 degrees. So we have the heat that changes temperature, which is mc delta theta. This is the way to consider your heat parameters. So pick up your past questions now, or you visit Fusion Mobile question paper and answer. Look out for all questions under heat and see how you can play around with them. Now also take a tedious study on latent heat of vaporization, latent heat of fusion, and meet me in the next section of physics clinic, where we'll make all things look so simple for you. But before that, let me bring the equation of conservation of energy in heat. For example, you plug in your boiling rings and use it to increase the temperature of the water you want to use in bath. The energy of the boiling rings is electrical energy, E equal to IVT, while heat energy, H, is equal to mc delta theta. So it simply means that since energy can neither be created nor destroyed, but can only be transferred from one form to another, we have it that E is equal to H. So IVT is equal to mc delta theta. Also, IVT equal to ml when you use that to change state only. Also, IVT equal to ml plus mc delta theta when you are using it to change states and also change what? Temperature. Now you have a work to do. Get me the other two equations of electrical energy. But I will write it down for you here. We have I squared r theta and v squared all over r times t. These are two other equations of energy. So depending on the parameters given to you, solve the questions for me. This will bring us to the next wonderful topic known as gas laws. Be there. I will be back in a jiffy.